Okay, this is day 2 of adding and subtracting rational expressions. Let's look at number 1. We have 3x over 4 plus x over 8. In order to find the, or create the common denominator, we need to multiply this by 2. Multiply the numerator and the denominator by 2, giving us 6x over 8 plus x over 8. Final answer is 7x over 8. Number 2, here we have our denominators of 6x, 3x, and 4x. So between 6, 3, and 4, the least common multiple is 12. This means we need to multiply this by 2, this fraction by 4, and this fraction by 3, giving us 2 over 12x, 8 over 12x, and 9 over 12x. So remember, it's plus and minus. So 2 plus 8 is 10 minus 9 is 1, so the final answer is 1 over 12x. Number 3, we have ab squared and a squared b, so therefore we're missing a b over here and an a over here. So the least common denominator is a squared b squared, so we need to multiply. As you can see, the a has been multiplied here to give us a squared. So a is up here, needs to distribute throughout. B is multiplied to the b in the denominator, giving us b squared. And now multiplied to the b up here, we need to distribute the b throughout a plus b. So now we end up with a squared minus ab plus b squared. Combining like terms, we see that ab and negative ab will cancel each other out, therefore leaving a squared plus b squared over a squared times b squared. Number 4, the missing factor for this fraction is a minus b, and the missing factor for this fraction is a. So we need to multiply a minus 5 over here, and we need to multiply this fraction by a over here. Distributing, we get 2a minus 10, and distributing here we get, well, we don't need to distribute that quite yet. So the final answer looks a little something like this. We can either have 5a minus 10 over a times a minus 5, or you can distribute your a, giving you a squared minus 5a, or you can leave them both in factored form, which is 5 parentheses a minus 2 over a times parentheses a minus 5. Number 5, as you can see, we have denominators that are not common, so we need to create common denominators. Let's go ahead and factor x squared minus 36. We know this is the difference of perfect squares, so we get x minus 6, x plus 6. And over here we can factor out an x, leaving x plus 6. So now we know that we're missing an x over here. And over on this fraction, we're missing an x minus 6. So remember, whatever you multiply to the denominator, you must multiply in the numerator. So x minus 6 times 1 is x minus 6, and x times 2 is 2x. Now that we have a common denominator, we can simply subtract, we can say 2x minus x minus 6, remembering to keep change. This negative will become addition. Let's negate the x and negate the positive, or the negative 6, making it positive 6. So as you can see, 2x minus x is x. And the 6 became positive, that's why it's x plus 6. And as you can see, the x plus 6 and the x plus 6 cancel out, leaving a 1 in the numerator, and the denominator is x times x minus 6. Last one, number 6. As you can see, we have 2x minus 6 and 6 minus 2x. So these are opposite factors. These are opposites, basically. So if we multiply, so this is sort of like the -1 method, except instead of that, we are multiplying by -1 in the denominator and the numerator. And if you multiply -1 times this binomial, you end up with 2x minus 6, or -6 plus. So then we can reorder this as 2x minus 6. The -1 times 9 is -9. And we have a common denominator now, so we have 3x minus 9 over 2x minus 6. And I guarantee we can factor out a greatest common factor of 3 up here, extract a 2 down here, leaving x minus 3 and x minus 3. Notice how both of those cancel out. Final answer is 3 over 2. And there you go, one extra day of practice on adding and subtracting rational expressions. Best of luck to you.